My name's Will. I'm at Protocol Labs. I'm going to be talking about private access to decentralized data. What I mean here is content addressed or hash addressed data, where we've got integrity, and thinking about how we build in privacy in our interactions with the data that we're using behind a lot of Web3 stuff. To set the scene and why we care, amount of data that we've got going up, exponential curve, but also our ability to compute and do analysis over that data also going up and to the right. And we're in an interesting time where, so this is a graph of just like internet freedom and the number of non-free countries going up, countries and people in power doing the analysis they can, increasing surveillance. We're headed on a path towards sort of a totalitarian, highly surveilled world. If we go there, going to be hard to get out. And it's pretty important that we think about how do we make surveillance on the large amounts of data we're creating hard. And we've got an opportunity to do that now. So I'm going to start by talking about, more specifically, the problem statement that we're going after and framing what is private access here. Then I'm going to go through a couple options. I don't have like a solution of how how the community should be approaching private data, but more there is a bunch of opportunity, and there are paths at least that we're going to be trying to prototype. And I'll finish off with sort of the things that seem most promising and how we want to sort of increase attention on this space. So let's start by defining what we mean when we're talking about privacy. There's a few different things that come in here. The first bit that you talk about is linkability. So can I link, or who can link between a user and the access, right? So that if we can de-link, if there is no way to correlate or gain an assumption, then you can talk about having unlinked. When you talk about unlinked, you still need to think about what is the pool size that the access could be confused with, and that brings you into a k-anonymity discussion of, is this access now within a couple people, or is it within thousands of people? And so you've got this concept of strength of anonymity that comes out of how large of a sort of additional set. Not all mechanisms will have this, but it ends up being common in many cases that you want to talk about sort of how much noise you've got. You've also got a bunch of statistical models that happen when you inject noise, and that ends up living in this differential privacy form. And so that's how much they know, how close or how much perturbation needs to happen in order to mask things. I've sort of been vague on who knows, but you've also got a threat model, right, that you're going to typically be bringing into. So any sort of anonymity that you're talking about is going to be in the context of the power of the adversary. And so is that adversary just some other user? What sort of resources do they have compared to a user? Is this someone who can surveil all of the links in your network or only a specific geographical region? Can they compromise nodes? And so the power that you're giving to your adversary ends up being probably one of the most important factors in what you can say about your privacy guarantees. Because there's always some adversary that can like do everything, right? If they can actually either if you give them the ability to break cryptography or give them the ability to compromise all of the nodes in your network, you've got nothing left. So it's what is this range between realistic and extremely powerful that you can set your adversary model to. Ends up being sort of one of the important dials in talking about anonymity or privacy. All right, so I've got IPFS here, but this is very much just representative of general distributed data. There's plenty of systems here. We're going to make this problem a little bit easier by talking about first a storage step and secondary a retrieval step. That storage doesn't necessarily need to be pushing, but it's an advertising. It's someone is publishing or making data available, and later someone is retrieving. And so you can think about those two steps differently, right? And so to make that like more clear about what I'm talking about, how do I get that storing or publishing step anonymous? In our world, I'm going to make that easy for myself by saying, get cryptocurrency, use a mix, Zcash, Monero, something to unlink it from yourself, go through Tor and send it to someone who's going to take Filecoin or something into a jurisdiction where it's legal. And if there's any jurisdiction where that's legal, you can probably push your data to some decentralized system and get it up there without it being linked to yourself. And the compromise here is that has pretty high latency, right? We're not trying to say I can like in real time publish new data to someone else. But if I'm willing to wait I don't know, half an hour or an hour to like go through these steps and have Tor, and I don't care about latency on publishing, I can eventually make data available in a decentralized way. And that's probably true with most of these systems, that we can get data up to some jurisdiction where it's legal, even if it's not legal in all jurisdictions, as long as you're willing to sacrifice latency. And so if we say that that's good enough for a lot of data, especially when it's immutable, then we can focus mostly on reader access, and how do you then pull down that data. Because pulling down the data ends up being sort of this place where if you're making data accessible around the world, you probably care about latency. And so getting that content and figuring out where that content is ends up being the hard part. So we can look at what's out there today in terms of how you would get data. The things that have scaled where you're getting a delinked user access are either onion routing or mixnets for the most part. So Tor is using onion routing. That means your request is going through successive indirection hops and also layers of encryption, such that between the entry and exit of the mixnet, there's no node that knows both the source and the destination of the request. NIM is doing a similar thing in a blockchain setting. The trade-off here is latency, again, that by going through 3 random nodes in the network, you're ending up with global latencies of hundreds of milliseconds at least to get much assurance of privacy. You can look at things like Signal, which are using full encryption of messages to hide the contents. However, their answer to access pattern privacy, so being able to know who's talking to whom, is both a central server, where they know, and also their ISP knows. And then for the really sensitive stuff like your address book, they're putting it into a secure enclave with SGX. And so they're just relying on a hardware security and that you trust Intel. So it's moving it to try and reduce scope, but there's not a cryptographic assurance here of an unlinking. That said, like, they're at orders of magnitude more than these other systems. And so there is this benefit where if you go to something that's just containing it centrally, but not having the latency impact, you can make a system that's more usable. So how do we get to privacy? So if you start with something like onion routing, you've got a bunch of options, which is that you should really be thinking about how do you make these sorts of systems aware of hash-addressed or self-identifying data. You've already got the hash. You don't need to go to a single origin, but rather you should be going to the replica of it that's closest to you. You've got a question of, can you learn this on the client so that the client, which is in a Tor-like system, source routing and choosing its hops, is able to choose those hops aware of where the various replicas are? Or is that something that your exit is going to do, where the exit is aware, like a IPFS browser extension or something like that, and is able to, instead of going to the actual origin, say, OK, this is a hash, it matches this URL pattern, I'm going to find the closest replica, or I'm going to have a cache, because since I can verify integrity at both of these stages, it's less that I need to go to the single origin as the trusted place here. We're working on, primarily inside PL, on thinking about how we go from the current model, which is a content routing of finding who has what, and that currently is a DHT, and how do we make that more private so that your request at least is not leaked to anyone other than the actual owners of content. As I said, right now it's a DHT. We want to give an abstraction that is logically centralized while still being decentralized so that you can reason about it as a database. We're setting up a bunch of really big nodes that will be able to have that whole data. And that then gives you the ability to apply a bunch of privacy techniques to it, even as we start to shard it. But it sets an interface that gives us a lot more opportunity to reason about the loss of privacy. So for example, as fully homomorphic encryption gets better, or as PIR increases in power, the expectation is that you can apply these techniques with a large central database to be able to start to answer questions, who has this given piece of content, without the server that's answering needing to know that. This may only work initially on the sort of hotter caches that are smaller scale, rather than the full content database. But for a large number of queries, that's going to be plenty. So if you look at all of the content that has ever been created or published that is hash addressed, that's going to be, I don't know, 10 to the 15th is our current estimate of where that is, and that's growing. But it's just like a lot of even just entries in your database line. You're not going to pull that out to a user's local ISP, but only like orders of magnitude less than that is ever actually accessed. And so even if you were just making a cache of every piece of content that's been pulled, that may be plausible to do these sorts of techniques over. Even if we don't get FHE in the next year or two down to a level of performance where we're going to be able to just apply it to put the entire database into an encrypted envelope where the server's oblivious, you can at least use two parties to blind. This is sort of like the common, I don't know, it's an easy solution, but it's not as strong of a thing. So you'd have one entity control an endpoint that people make queries to. It strips off one layer of encryption and then makes the queries back to a different entity that controls the actual database. So the database lookups doesn't know the individual sources and can't link them back to the users. But you could have both of those in the same data center and not end up with much latency impact. Cool. I'll end by saying that we're also putting a bunch of funding and spinning up a funding program around this problem. This goes under a larger effort that PL has been working on called Funding the Commons. You can find more about it at fundingthecommons.io. But we're spinning up, trying to fund at least 5 projects, both academic and implementation or prototyping, of additional mechanisms around anonymous communication. And basically the thought is, when we get to 5 years from now, we don't want to just be looking at this and saying, well, okay, the only thing that's got over 1 million users is mixed-nets. Like, there's nothing that doesn't do latency as the trade-off. We think there are other mechanisms. We have seen other mechanisms that are already in academia, but just haven't gotten to prototype or implementation phases. And so we want to help get prototyping happening on these other mechanisms. And then we also think there's plenty of more mechanisms and lots of stuff moving fast. There's a QR code that links to an open problem. That'll get updated with a submission site over the next month as this finalizes. We've got an external review board that's going to look at proposals, but we're expecting this to be a couple million a year that we're pushing towards external groups, generally thinking about how do you deal with anonymous retrieval, and especially around content addressed support, although even not strictly that. Cool. So I think I'm about on time. I can take some questions. All right. Thank you.